All right, you guys, please share in the chat thoughts, comments on how did it go for you guys using one method, and I'm going to show you guys the answers. I did both methods, and then I'm going to correct one of my problems just to share with you guys what I did incorrectly at first. I didn't want to erase it because I wanted to show that this sometimes happens. So I didn't read the problem at first, and I just saw create a Maclaurin series, and I didn't see fourth degree, so I'm going to clarify that. In pink, I'm going to do make a correction. On the left-hand side, that's the shortcut way. If you did the shortcut way, what you should have done was written out the cosine of x template, and then from there, really, you don't need anything beyond this. So my correction is that I'm going to cross off the general term, because if it's a fourth degree Maclaurin series, you stop at the fourth power. So fourth degree, and then sometimes they might say the number of terms instead of the degree. So in parentheses above, if you guys can say, these are some other various ways of saying the same thing. It might say fourth order. Fourth order is the same thing as fourth degree. Or for this particular problem, they might say, or three non-zero terms. Okay, so all these mean the same thing as the answer that's provided, and the correct answer for this particular problem goes only up to the fourth power. So please ignore what I wrote here. And if you cross-check that with the long way, the Taylor series way, let me move this chat so everyone can see this here. The long way, the Taylor series way, is to crank out the function value evaluated at 0, the first derivative, second, third, all the way up to, you know, when to stop. If it says the fourth degree or the fourth order, the highest derivative you have to get to corresponds with that. So in this case, the fourth derivative is what I got to. And then after that, you plug in whatever a is. And if a is 0 for the Maclaurin series, you plug in 0 into this whole string of calculations here. And these are the values that I got when I plugged in x equals 0. Then take those values. If this is the first function value, has nothing to do with the derivative, that's going to be the constant that starts off your Taylor series. So 1. And then from there, this is what we call a 0 term. Okay, if I have a 0 on top of a fraction, it's going to 0 out my coefficient. So I'm not going to have an x to the first term. And so that's why we skip over x to the first when we're looking at the cosine template series. And then moving forward, you guys have -4 corresponds to this -4. That's the second derivative over 2 factorial x squared. Okay, if we continue that pattern, the third derivative happens to be 0, so that's a 0 term. Then 16 is the next one. So this 16 I plugged in here over 4 factorial x to the fourth power. Okay, so now those are the basically last week's stuff, Monday stuff, all merged in together. This is what we would expect you guys to be able to do. If this was the AP test, please do it this way if it's a Maclaurin series, because it's much faster. If you're not sure, because there's just so many manipulations that occur, do it the Taylor series way. Okay, nothing is, if you use either one of these methods, it's correct, but it's nice to be able to see it side by side. On the test, if you guys, on the quiz this week, if you guys see Taylor series, if they don't say Maclaurin series, but they say it's Taylor series centered at 0, again, please keep in mind, you guys can use the template series for that. So that's basically what I need you guys to be able to get from last week's stuff and this week's stuff, and just basically kind of seeing all of those put together. Now what we're gonna talk about, and what's pretty neat is, that's great, Mrs. Kim, this is a good approximation, but what happens if I don't want it to be just centered at 0? Because I know if it's centered at 0, it's a good approximation there, but what if I wanted 1 over 1 minus x to be a good approximation somewhere else, like at x equals 2 or at x equals -3? So guess what you guys are able to do with polynomial series or polynomial functions, or any function when you guys are in pre-calc? You can pick up the function, shift it left and right, and that's what a Taylor series does, is it takes a Maclaurin series. Next page. On the next page, you guys have the Taylor series is basically, let's shift the center. If we want it to be a good approximation somewhere else, let's go ahead and shift the entire series to that new value. So you'll notice that, please take note of the difference that you guys see here between this and what we just did with Maclaurin series. So Maclaurin series is specific. Maclaurin series is, the A value is 0. So notice that if I were to plug 0 into all my A's, that I would get the Maclaurin series way of doing things, or the Taylor series. I've been calling it Taylor series because Maclaurin series is that, just centered at 0. And so if you don't want to memorize the Maclaurin series, just memorize this formula. It's the same exact thing, except now instead of plugging in x equals 0, we might plug in x equals 2. And if you think about it, these are all just shifting the entire series by subtracting a value. So if you guys subtract something from x, it's shifting it right or left to basically move the center to where we want it to be so that it becomes a good approximation there. So in the example below there, I'm going to make a big note about this, and this is going to be something you guys want to think about for your test. If you are not centered at 0, do not use the template series, okay? The template series are a common Maclaurin series. So remember, these are only centered at 0. So I don't know if you guys want to make a big note of that. So one of, the big mistakes that I see on this upcoming quiz is using the template series when they want you guys to generate a Taylor series not centered at 0. So there is no option. If it's not centered at 0, you can't use the template. You have to do it the long way. They will account for that. They know that that takes time. So part A, this is an example of something that would probably take or be 4 points on the AP test for part A, because you do have to go through and generate, and it takes time. So I want you guys to, again, do the same thing with the people that are in your call right now. Can you guys go ahead and come up with the first 4 terms and general term for the Taylor series? So again, what you're doing is coming up with successive derivatives and then plugging in A into all of those functions and, well, functions and derivative functions. And A in this case is 1. It's centered at x equals 1. All right, you guys. So all I did was just come up with the derivatives and plug in plug in 1 into all of those. So a couple of notes. Why did I stop at the 3rd derivative? Can you guys type into the chat? Why did I stop at the 3rd derivative? Okay, yeah, so it's a subtle difference between the answers, but if you guys put in an extra term, in the free response, they actually put notes, -1 for extra terms. So kind of like petty, but something that I just want you guys to be aware of. So if everything's right, but you guys just have an extra term, then it's not going, it will mark you guys off for that on the free response, or it, or they, or he or she. So just make sure you guys read it carefully. It says first 4 terms, so the constant counts as a term. And then from there, I have a note in my notes that says write out what you guys are doing for this problem, because what happens is that I think, especially as you guys are practicing this on the homework, there's just so much to it. It really becomes methodic after a while, but at the beginning, there's just sloppy mistakes like I forget to include this or I forget to include that. So as you guys are just beginning this process, I would suggest writing out the Taylor series at first. So in this case, like you want f of 1, then the next step would be take the first derivative at 1, put it over 1 factorial, x minus, we're shifting it to the center of a, so x minus 1 to the first power, and just getting into the habit of recognizing everything that needs to go into a problem like this. And I know it's tedious at first to do this. I would suggest you guys do it until you feel comfortable, until you know you're not going to make the mistake of dropping either the factorial or the x term. I will tell you guys that, so I'm going to count out the terms here for you guys. This is 1 term, 2 terms, 3, 4 terms. And I will tell you guys the biggest mistake, besides using a Maclaurin series as a template instead of cranking out all the derivatives like we just did and plugging in 1. Okay, so one mistake is plugging in 0 at this point. Okay, we want to plug in the center. We want to plug in x equals 1. That's one mistake I see. The other mistake I see is doing f of 1, f prime of 1 over 1 factorial, but basically not including x minus 1. So think that you guys are coming up with a polynomial. So there has to be an x in it. So if you guys drop out the x and all you have are just these values, these are just coefficients. So then if your answer is just like numeric at the start, it's not going to make any sense. Okay, so make sure you don't drop the x portion of each one of the terms. Okay, after that, just plug in from there. You don't have to simplify anything. So e to the negative 1 plus negative e to the negative 1 over 1 factorial. On your test quiz coming up, because it is a free response, you guys do not have to simplify even the factorials. You can leave that alone. Okay, sometimes what they'll say is you basically want to start to think about the fact that this is the actual function. This is your Taylor approximation for it. Sometimes on a free response, they only give you guys one or the other. Like sometimes they'll give you f of x, they'll give you what the function is. Sometimes they won't. Sometimes they'll give you guys these values and just come up with a Taylor series. So the thing you want to keep in mind is that if they want you guys to use it to approximate something, if all you have is the series, you're just going to take that 1.1 and input it into all your x's. In this case, they want an approximation using the 3rd order polynomial that you guys just came up with. So that would be this one, and plug 1.1 into all your x's. This was not, I don't think I treated it as a calculator question. So go ahead and plug it in and then just leave your answer. So you can say that f of 1.1 is going to be approximately, and then plug in 1.1, see, and then, well, you don't have to see what you get. 1.1 minus 1 is just 0.1, so I'm just going to put 0.1 in there. Or once again, you actually technically didn't have to simplify that. This is very similar to your quiz questions, by the way, as we're doing this. Okay, good question. Oh, yes, I did not read that carefully. Thank you, Sophie, for pointing that out. For part A, it says, write the first 4 terms and the general term. I didn't include the general term for the series. I thought it just said write the first 4 terms. So let's go ahead and come up with what that general term is. Notice that in each one of your terms, you guys got an e to the negative 1, which is essentially a constant, but that constant is alternating. Okay, so we're going to incorporate in the alternating piece to it, which is negative 1 to the nth. So I'm going to include general term down here. Why don't you guys actually try to see if you could come up with it before I tell you what the answer is. See if you guys can come up with a general term, just in a minute. Some of you guys probably already did it. Just go through each term, what's in each term. Double check, do you guys have the same general term? Morning. Good, how are you doing?
Doing good. Doing good.
All right, you guys, part C. Again, these are individual questions on your quizzes, very similar. No, you do not have to write the summation notation with the sigma in front of it unless it's just like you don't have any terms and they just want a sigma notation alone with the general term. That's just one way of summarizing the series. So this series is considered expanded out with the general term. If you have a sigma notation, you don't need the first four terms because this one basically gives you the rule for it and you just have the sigma notation in front of it. On the AP test, they don't really ask you guys to rewrite it in sigma notation. I think given sigma notation, they expect you guys to be able to answer the questions, but good question, you don't need that. So one other thing I'm gonna bring up, which I had a realization or a thought to myself, I'm like, how come I don't mention that earlier? So I'm gonna mention it now for you guys as we finish off this problem. Can I have you guys do part C and then you'll double check your work with mine? But go ahead and do the first four, and four is spelled incorrectly here, four terms and the general term for the Taylor series for x squared times f of x at x equals 1. So I know that this is going to be a manipulation that I do to my series and not my original function because we have first four terms and general term. Okay, go ahead and write what you think the answer for that is. So super easy, you guys. Just remember, you can do things like multiply both sides of your essentially equation by x squared. So all I did was in multiplication and division, it's term by term. So I basically times each term by x squared, and you guys can see the x squared being incorporated into all my terms, even my general term. And then that's it. Okay, so division, you divide every single term by it. If it's subtraction or addition, just add it to the constant. So if it's like +1, I would add it to, since there was e to the -1 at the very start, it's not like you can really simplify that. So I would just have, if it was f of x +1, I would just incorporate a +1 once because that's a constant I'm adding to both sides. So think of it as a giant equation. So the last thing I'm going to mention down here, I think I made a note here to make sure that you guys add that into your notes, is that And actually, why don't you guys type out into the chat for me? When I'm looking at this, let's go back to part A at the series that I have here. I'm circling. Can you guys type into the chat what part of the general term is considered the coefficient? What part of the general term on here is considered the coefficient? So if the test said this is the coefficient, they refer to a coefficient, what part of that is the coefficient? Think of what a coefficient is. Yeah, so one of the most confusing types of free responses I think that students get initially, and you guys are gonna cry, some of you, when you see some of these expressions that they have for the coefficients, but sometimes all they give you guys is a rule for the coefficient. Okay, so if they say coefficient, they're referring to the number that is in front of x. So when I'm looking at my term, this is the x portion of it. So anything that comes prior to x minus 1 to the nth is considered my coefficient. So down below here, the coefficient on a Taylor polynomial is going to refer to the nth derivative at a over n factorial. Okay, so it's all of the derivative part of it, the factorial part of it, that's all part of the coefficient. Okay, so just kind of keep that in mind, as so sometimes that aspect of it is important for certain analysis that we're going to see in free responses that we're actually the one that we have coming up, it's going to become important for that as well. Okay, so we'll get to more advanced questions on that, but for now, just realize if they say coefficient, it's all of the things that are in front of your x term, including the alternating part. Yeah, the negative 1 to the nth is included in the coefficient as well. This is just a generalized coefficient for all Taylor series, not for this one particular problem. But yes, if I were to circle the coefficient for that general term, all of that is the coefficient. Okay, so let's move on.